So let's start. In the previous class, we have discussed about all the transducers we have discussed. Okay. Yes or no? Is it audible, visible, screen is visible? Anyone reply? Hello.
Yes, sir.
Okay. Thank you. At least one person to reply there, at least. So here we'll start, that is instrument transformers here now. So the name itself, it is saying that instrument. So instrument, the transformer. Anyone, can you tell me what do you mean by transformers? Any one of you? See, the fourth unit, it has two parts. One is related to the transducer, another one is related to the instrument transformer. One part is over already. The second part we have started, that is called instrument transformer. So any one of you can tell me, define transformer. Or what do you mean by transformer? I don't want exact answer as it is. What do you mean by transformer? Transformer means what? I will wait up to your answer. जब आप आंसर बोलेगी तब भी मैं आगे जाता हूँ.
Transformer is a static device which converts one form of energy to another form.
One form of
Power to another form.
Once again, please. Transformer is a static device. कौन बोला अभी? और एक बार बोलो. Project with Patel. Okay. See, actually, it is not going to transfer one form of energy to another form. One form of energy to another form is nothing but that is transducer. But the transformer, it is going to transfer the electrical energy from one circuit to another circuit. From one circuit to another circuit. Here, see the transformer symbol we are going to draw like this. This is one circuit. This is one circuit. Another circuit, it is not connected to that one, but we will get the electrical supply in the another circuit here. How we will get that one? That is mutual inductance here now. Due to the induction method, we are going to get the supply here now. So here we have giving the supply, electrical supply. Here we are taking the electrical supply here now. So the transformer is a static device, static electromagnetic device, which transfers electrical energy or power from one circuit to another circuit at constant frequency or without changing the frequency here now. See here 50 hertz we are passing here now. For the same 50 hertz, it is going to induce EMF in the secondary winding. Here also at same frequency of the supply also it is correct, or at constant frequency also it is correct. So this is transformer we are going to call it. It has if the voltage level is increased, that is step up transformer we are going to call. If it is decreased, that is called step down transformer we are going to call here now. So same thing for the instrument purpose. Instrument purpose means to connect to the emitter, voltmeter, energy meters and all the things. For the measurement purpose, we are going to use the instrument transformers here now. That is called instrument transformers. So the instrument transformers we are going to use in the AC system for the measurement of electrical quantities like voltage, current, power, frequency, power factor. These all the things we can measure from the instrument transformers here. Just a minute. Sorry for the interruption. So we can measure the AC quantities or electrical parameters, that is voltage, current, power, energy, power factor, frequency. These all the things. To measure that one, we need the instrument transformers here. So the instrument transformers are also used with protective relays for the protection of power system here. So the relays we are going to use in a power system, and circuit breakers we are going to use for that circuit breaker. Okay, no problem. To measure the voltage, current. Suppose I will give one example, that one. You nearby substation, suppose you have 440 kV supply is there. How you are going to measure this 440 kV? Is it possible to measure 440 kV? See, for the 230 volt you are getting in your house, only 230 volts, 230 or 240 volt you are getting in your houses. You just try to connect one ammeter for that one. This is 440 kV is nothing but 440 into, that is 4,40,000 volts are there here. 4,40,000 volts here. So this is measurement is difficult, and for the insulation we have to do costlier. So the whatever the setup is there, it is very costlier. That for that reason they have invented the instrument transformers, which one it will bring this 440 into the measuring voltages around 100 and 200 volt. With respect to that, we are going to measure the voltages, current, power, energy, and we can measure here. Based on that, it is going to bring into lower voltage, lower value it is going to bring that one. So protective relays also. Basic function of instrument transformer is to step down the AC system voltage here or current here. It is going to step down from higher voltage to the lower voltage, higher voltage to the lower voltage. It will bring this voltage, and higher current to the lower current it is going to bring that. This is the basic function of the instrument transformers. आवाज आ रहा है क्या? कोई रिप्लाई नहीं दे रही?
Yes, sir.
Okay. So the voltage and current levels of power system is very high. Our voltage level, I told that one, it is very high. Example, सबका घर को सप्लाई कहाँ से आ रहा है? आपका ट्रांसफार्मर से आ रहा है. एक पोल माउंटेड ट्रांसफार्मर है ना आपके घर का बाजू, एक पोल में इधर ट्रांसफार्मर बिठा है, 3 वाइंडिंग्स, 3 lines, 4 lines. Yes. So from there you are going to get that one here. Actually for that transformer the input is 11 kV, but the output is 440 volt, that is 3 phase here. From this output 440 you are taking only single phase supply, one phase to a neutral, that is around 240, 230 to 250 volts you are taking that one here. That is the single phase supply here. So the voltage and current levels of power system is very high. You can see this one, the substation I told that one, 440 kV, 210 kV, 110 kV, like that. We are using the very higher level of voltages we are going to use over there. So for that, to measure the higher level of voltage and current to set up in the measuring instrument, it is very difficult and costly also. So it is very difficult and costly to design the measuring instruments for the measurement of such high level voltages and current. To measure the high level voltage and current, it is very costly and very difficult. For that reason, we are going to connect the instrument transformers. The instrument transformers are mainly classified into two types. So you are the direct second year students, you should know that one at least. What are those two types? Two types of instrument transformers. Yes?
CTPT.
CTPT, very good. That is called current transformer and voltage transformer. Generally, what we are going to do, for the current transformer, we are going to bring the current from the higher current to the lower current. That is called up to 5 ampere. We are going to bring that one. From the potential transformer, from the higher voltage up to 110 volts, we are going to bring here. Generally, the measuring instruments are designed for 5 ampere and 110 volts. We are going to design this one here. So this is the basic introduction of the instrument transformers. Introduction of instrument transformers. So the application of instrument transformers, where we are going to use the instrument transformers, exactly in which places we are going to use. That is in the substation we are going to use, or in the houses we are going to use, where we are going to use. Actually, these all the instrument transformers we are going to use in the AC system we are going to use. So for the measuring of the high current value, that is, we are going to use the current transformer we are going to use, and to measure the voltage we are going to use the potential transformers. To measure the power factor, and that energy, this one we are going to use both potential transformer as well as current transformer. Both we are going to use. These two are the three applications are there for the instrument transformer. To measure the high value of the electric current, that is called current transformer we are going to use to measure the high value of current. To measure the high value of voltage, electric voltage or potential difference, that is called potential transformer we are going to use. To measure the electric power with uses of CTPT, we are going to use both uses of CTPT. Now these two are the three applications of the instrument transformers. So here it is introduction of the instrument transformer will complete here. Now if you have any doubts, sorry, advantages are also there here. See here, what are the advantages for the using instrument transformers? We have discussed about what do you mean by instrument transformers, where we are going to use the instrument transformers. Now we have to discuss about some advantages of instrument transformers. See, where the large current is there, voltage is there on that system, it can be used by taking small rating of the measuring instrument. That is called 5 ampere, 110 volt, 120 volt. So that is the advantage only. No need to use the 440 volt kV rating voltmeter and all the things. By using 110 volt or 110 volt rating of the measuring instrument, we can measure. So that is possible because of the instrument transformer here now. So that is the first advantage here. A large voltage and current of AC power system can be measured by using a small measuring instrument here now. That is called small rating measuring instrument. The rating of that instrument is 5 ampere, 110 volt, 110 to 120 volt here now. So that is the first advantage. The second one, the instrument transformers provide electrical isolation between high voltage power circuit to the measuring instrument here. Here the high voltage is there. आप लोग सुना है शायद in the area, some areas what will happen, there is no exact planning for the electricity. इधर ही घर रहते उसका ऊपर ही ऐसा what is that one, electrical wires will be there. Someone if it is touched or not touched for around 1 meter difference is there. If suppose 440 kV volt is there, 1 to 2 meter it will produces the electromagnetic field will be there. So electric field will be there, it will give the electrical shock to that person and they will get expired at the spot. So it should not happen for the measuring person and measuring instruments. For that reason, the instrument transformer, what it will do, it is going to provide the insulation between the higher voltage side to the measuring instrument here now. So measuring instruments and protective circuits also assures that safety of the operators here. Who is going to operate in that one, it will assure the safety of that one. That is the second advantage of the instrument transformer. Third one, several measuring instruments can be connected through a single transformer. One single transformer we have used. We can connect voltmeter, ammeter, power meter, energy meter, frequency meter, power factor meter. Several instruments we can connect that one. That is the third advantage of that one. The fourth one, due to low voltage and low current level in measuring and protective circuit, there is low power consumption. The power consumption will be very low for the measuring and for the protective circuit here now. It is very low power consumption here now. So that is these four are the advantages of the instrument transformers here. So it completes the basics of instrument transformers. Instrument transformers are mainly classified into two types, that is called current transformer, potential transformers here. So we have started the discussion of instrument transformer. What do you mean by instrument transformer? We have discussed application, advantages, and types of instrument transformers. If you have any doubts, you can ask me. Any doubts here? Any doubts? I'm asking to you people. Any doubts? Why you people are sitting silently? Give the reply. Hello? Is it audible or not? Hello? Is it audible? Anyone reply please?
Yes, sir.
How much time it will take to tell yes or no? Simply you people are wasting the time. Then it indicates that you people are not listening at all. Just for formality you are attending the class. It should not be repeated like that. So we'll go for the types of instrument transformers. There are two types of instrument transformers are there. Those are current transformers and potential transformer is there. So one by one, before starting this deep discussion of this potential transformer and current transformers, what I will do, we'll discuss about some ratios we are going to discuss, because already we have studied this transformer information over there. So the ratios of instrument transformers we are going to discuss here. Instrument transformers means it is not particularly for the CT and PT separate. It is combination of CT and PT with general definition we are going to consider. So the first one we are going to discuss, that is called transformation ratio here. So the transformation ratio is nothing but it is the ratio of magnitude of the primary phasor to the secondary phasor. We are using two windings, that is one is primary, another one is secondary winding. We are using two windings we are going to use, primary and secondary winding. Whatever the phasor value, the magnitude of, suppose whatever the magnitude of this voltage is there and magnitude of this voltage, that is called V2 we are going to call. So it is going to give the ratio of this one primary V1, magnitude of V1 divided by magnitude of V2, that is called the potential transformer. It is going to apply the magnitude value. If it is instead of this one, we are going to use that is I1 divided by I2. That is called current magnitude or current transformation ratio. We are going to call that. The transformation ratio is the it is the ratio of magnitude of the primary phasor to the secondary phasor here. So that one only we have written in the definition in the formula here. Now transformation ratio, that is called, it is going to represent as R here. No, it is the magnitude, that is called phasor. It is going to indicate here. No, magnitude of primary phasor to the secondary phasor. So if it is current, this primary phasor will be current, primary current to the secondary current, that is called for PCT, current transformers. If it is voltage, then that is called PT here. No, instead of this phasor, if we have used primary current to the secondary current, then that is current is nothing but current transformer. Primary voltage to the secondary voltage, that is called potential transformer. We are going to call it. Is it clear? Roll number 10 and 12. Are you there or not? Roll number 10 present, 12 also present. Roll number, हाँ, समझ में आ रहा है? Roll number 12.
Yes, sir.
Okay. So next ratio is called, that is called nominal ratio. We are going to call that. That is nothing but nominal ratio here. Now it is the ratio of nominal ratio. Some little difference is there actually. So not nominal ratio, turns ratio. Okay, nominal ratio, there is no difference again. Here it is the ratio of primary current to the secondary current for the current transformer. If it is voltage potential transformer, then primary voltage to the secondary voltage we are going to call that. So the nominal ratio, that is called Kn, it is going to represent here. No, rated value we are going to consider here. Now rated primary current to the rated secondary current, that is called CT. And if it is rated primary voltage to the rated secondary voltage, that is called potential transformer. It is the ratio of primary, it is the ratio of rated primary voltage to the rated secondary voltage, that is called for potential definition, potential transformers. It is the ratio of rated primary current to the rated secondary current, that is called nominal ratio of the current transformer here. This is the definition of the nominal ratio here. So transformation ratio, nominal ratio we have discussed, but for the turns ratio here now, turns ratio, that is little bit different is that here. Now it is fully opposite to each other. CT and PT both are opposite to each other here. Because the turns ratio of the current transformer is the ratio of number of turns of secondary winding. Secondary winding में कितना turns है to the number of turns in the primary winding. For the ratio of now turns ratio of the CT here now, I will write CT here now, is the number of turns of in the secondary winding to the primary winding. We are going to write like this here. I2 by I1. For the potential transformer turns ratio, it is number of turns of primary winding to the number of turns of secondary winding. So that is N PT we are going to call turns ratio. Turns we are representing as N here now. That is V1. Sorry, just a minute. N1. This is completely wrong. Just a minute. I1, I2 use nahi karne ka. N1, N2 have to use that. So the number of turns in the secondary winding to the number of turns in the primary winding, that is for the CT. But for the PT, the turns ratio is number of primary turns in the primary winding to the number of turns in the secondary winding we are going to calculate. Is these two are both are same or is there any difference here? You tell me. This equation, you compare both the equations. You compare both the equations, you compare and tell the difference. Is there any difference from this one and this one? Difference तो है क्या नहीं? Is there any difference? Rule number 10. Are you there? Rule
Yes,
number
sir.
10.
Yes, sir.
Is there any difference here comparing these two equations? Yes. Rule number 10, I am asking to you only. Check karo formula. Rule number 10. Unmute first. Bolo Anisha. See, this is N for the CT. This is N for the PT. For the CT, the turns ratio is secondary winding turns to the primary winding turns. For the PT, it is primary winding turns to the secondary winding turns here. N2 is nothing but number of turns in the secondary winding. N1 is nothing but number of turns in the primary winding here. Number of turns in the primary winding. So now you can tell, is there any difference? Now can you tell me? Rule number 10.
N1 is the
वो नहीं बोलने का इधर, ये CT के लिए टर्न्स रेशियो है. दिस इज फॉर द CT, दिस इज फॉर द PT हियर. नो पोटेंशियल ट्रांसफार्मर में अभी हमको टर्न्स रेशियो मेजर करना है तो प्राइमरी वाइंडिंग टर्न्स टू द सेकेंडरी वाइंडिंग टर्न्स यूज करते हैं, और CT में करंट ट्रांसफार्मर में हमको टर्न्स रेशियो मेजर करना है तो secondary winding turns to the primary winding turns. These two are the reverse we have to use here now. This one you have to remember. Otherwise nominal ratio में कुछ नहीं difference नहीं है, और वहाँ पर the transformation ratio में कुछ difference नहीं है. Only difference is here, that is in the turns ratio there is difference here. Okay, is it clear?
Yes, sir.
So next we'll go for the current transformers we are going to discuss here now. So the definition of current transformer is nothing but it is a device that is used for the transformation of current from a higher value into the proportionate current to the lower value. So it is a device. The current transformer is a device which transforms the electric current from higher value to the lower value. It is going to transfer the higher value to the lower value. That is called current transformer. We are going to call that. That is called current transformer. So it transforms the higher voltage current here, higher voltage current also here now, high voltage current into the low voltage current. That is also important here now. So it can also transform voltage high hai aur uska current ratio high hai. Then also that current also it is going to bring that one into low voltage current value here now, due to which the heavy current flows through the transmission line is safely monitored by the emitter. Heavy current whatever it is there, we can monitor by safely, we can monitor that one without any harmful. It will provide the security and protection to the measuring person who is working in that area and all the things here. Okay, this is the current transformer definition here. Now it is a device which transforms electrical current from higher value into the lower value. You can tell that one. That is called current transformer definition. So the current transformer operation here. See here. This is the current transformer. This is the current transformer. The diagram is visible. See the RYB three phases we are using here now. This is R, Y, B here now. So the phase is acting here now, as one phase is acting as the primary winding here. One phase will act as primary winding here now. See the B phase is connected to the CT. I am connecting here now. So this winding here, it is connected, the primary winding is connected in series with the B phase here now. Series में connect होगा क्या नहीं है? The primary winding is connected in series with the B here now. So then the secondary we have taken to the another side, which one it is directly connected to the emitter. It is connected here now. Emitter, it is connected here now. One ground supply we have given here now. whatever the excess voltage is that one we are going to sending into the ground to avoid the hazards like a high voltage and all the things here. Okay, listen carefully now. So the EMF will induces here in the secondary winding because of current flowing in the primary winding. EMF will induces here now. So the number of turns are more in the secondary winding. So then it will step down the current here now. So what will happen here? We are using one switch here now, and here we are connecting one ammeter here now. The ammeter, whenever we want to measurement karna hai, then the switch should be open here. The switch should be open. The current will start to flow through the ammeter here now. It will start to flow through the ammeter and it will give the current and it will go back to the main supply. If we want to remove this ammeter, no need to remove the whole CT here now. Just we have to short circuit this one here. Then what will happen? The current will continuously flow here only. Yes or no? The switch for connecting and disconnecting the ammeter in the circuit here. By closing this switch, we can connect, we can remove, disconnect and connect the ammeter here. So the primary winding, the conductor or phase is act as a primary winding here now, or the primary winding is connected in series with the phase here now. One of the three-phase supply system line, it is connected here now. So this is the power conductor here. So this one is the working of the current transformer here. That is working of current transformer. Same thing they have written here now. The primary and the secondary windings are insulated from the cores and each other. Both the windings are insulated from the core. Core material is that is insulated here now. The primary winding is a single turn winding, also called as bar primary winding here now. See, this winding is here, they have shown number of turns here, but it is bar type only. Directly I told that one. The one of the phase or line is act as a primary winding here now. It is going to act as a primary winding here now. Very good. So the secondary winding of the transformer has a large number of turns. It has n number of turns. It has the secondary winding. So the primary is connected in series with the power circuit. Already I told it is connected in series with the power circuit, or it is that's one of the conductor. It acts as a primary winding over there. So therefore, sometimes it is also called as series transformer. Also, we are going to call it is the winding is connected in series to the power line. So for that reason, the name we are going to call as series transformers. Also, we are going to call here. Now, secondary is directly connected to an ammeter here. The ammeter, it is connected directly to the ammeter. We have provided one switch for the disconnection and connection of the ammeter here. Now, directly connected to the ammeter. As the ammeter is having very small resistance here now, hence the secondary of the current transformer operates almost in short circuit condition here. If the current, if the resistance is less than higher, current will flow more or less current will flow for the low resistance. Simple question. What is the relation between resistance and current? R is inversely proportional to the current here. No, reciprocal, inversely proportional. If the high resistance is there, the current will not flow over there. It is going to stop the current here. The resistance is nothing but flow of opposition, flow of electron, opposition to the flow of electrons over there. So the ammeter has very less resistance is there. It will flow and it will continuously, it is going to operate that one. All current it is going to take. If we want to remove this one, then we have to short circuit here now. Very small resistance था, उसको short circuit करने के बाद resistance will be zero. On that condition, zero current will flow here now. If this resistance is zero, no current will flow here now. So whole current will flow through this one only. And that time we can remove and we can connect the switch over there. We can connect the ammeter here now. So this is the short and simple explanation of the current transformer here. Same thing we have written here now. One terminal of the secondary is earthed to avoid the large voltage on secondary with respect to the earth here. So we have connected here one terminal. We have connected here now. See here, it is connected to the earth. Suppose anytime lightning arrestor and all the things occurred, suddenly it is going to bypass that excess voltage here. So considering the ground resistance here now, so you have kept this one less than ground resistance only, this emitter here now. So less than that one means all current will come here now. If it is more than that, then excess will be there. Suddenly it will go to the ground. It is going to go over there, which in turn reduce the chances of insulation breakdown. Because of high voltage and all the things, the insulation breakdown or washout will have occur over there. So to avoid that one, so we have used that insulation, that is grounding terminal we have used over. Moreover, before disconnecting the emitter, the secondary is short circuited through a switch yes and shown in the figure to avoid high voltage buildup across the secondary. To avoid the high voltage buildup across the secondary, so what we have to do, I say connection here, though it will build a high voltage over there. So we have to close this switch while removing this emitter here. While removing the emitter, we have to close that switch here. So this is the construction and working of a current transformer here. Current transformers. Any doubts? Doubt? All right, easy subject. This chapter is, I think it is easy only, but for you people, I don't know. Is it easy? Understanding? बहुत सारे लोग लेफ्ट हो गए, मीटिंग ही लेफ्ट हो गई, कुछ भी एक्सप्लेन करो. Roll number 14, Prajakta.
Yes, sir.
Is it clear?
Yes, sir.
Okay. So next we will go for different types of current transformers are there based on their construction and their connection. Here now we have three types of transformers are there: wound type current transformer, toroidal type, and bar type we are going to use here now. So the current transformers are mainly classified into three types here now. So this is the wound type. Wound type means like this is a one tank we are going to provide here now. Inside that we are going to fix the primary winding, secondary winding, that is called wound type current transformers we are going to call that one here. Rule number 4. In this transformer, the primary winding is composed inside the transformer. Primary winding is composed inside, we have kept here now. So magnetic core we have used. The primary winding had a single turn here. No, only one turn is there, primary winding. Yeah, and connected in series with the conductor that measures the current here now. Directly to the line voltage where we have to connect. Directly it is going to connect in series. One terminal either connect ho jayega or either wound type transformer rehte. Another terminal it will go to the connect here now. Next, the secondary winding we are connecting here. And we are going to take those two terminals and we can connect into the emitter here. Emitter or measuring circuit we are going to connect here. That is wound type we are going to consider. The second type, that is called bar type, is there. Bar type means we are not going to use anything here now. That whatever the conductor bar is there inside, that one we are going to use the square one, clamp one, toroidal here now. So this is example for this diagram is example for bar type and this toroidal current transformer here. Both are same only here. So this bar we are using here now. This symbol is like a toroid is there. For that reason, toroidal we are going to call here. Bar type current transformer is the bar type transformer has only one secondary winding here. इसमें only secondary winding ही है. The conductor on which the transformer is mounted will act as primary winding here. Now this whatever the bar is there, it acts as a primary winding. The secondary winding only it has here. Primary winding है क्या इसमें कुछ? Only secondary winding is there. Whatever the main line is there, this main line, this one, it is going to act as a, that is primary winding here. It is going to act as a primary winding. See here, it is like this. The transformer is there. We are using this one as the pen we are going to use as a primary winding here now. This is only bar type is there. So for that reason, the name came here as bar type current transformer here. Once again, I will read. The bar type transformer has only secondary winding here now. See here. Here the secondary winding I have done here now. Is there any primary winding I have done like this? No. So this bar is there, whatever the transmission line is there, we are connecting three lines here now. One of that line are the phase of that the power circuit that will act as a primary winding here now. It will act as a primary winding here. So the name came, that is called bar type transformer, the name came here. But the toroidal material we have used here, which has surrounded the bar type conductor, that is called primary conductor. So the name came, that is called toroidal here now, toroidal current transformer here. This transformer does not contain primary winding. It has any primary winding here? No. I will just a minute. I will add this one also. I will add the. So this type of transformer does not contain, it does not contain any primary winding here now. Here there is no primary winding here now. The line through which the current flow in the network is attached through a hole. Here we have made a hole here now. This line it is going to make through pass through this one here now. So that the major advantage of this transformer is that the transformer has a symmetrical shape due to which it has a low leakage flux, thus less electromagnetic interferences are there. So this one we are going to, the toroidal shape is there. So we are going to use this one as toroidal shape, the current transformers here. Just a minute. See here, is it visible? The diagram is visible. Just a minute, you check it. I'll stop sharing here.
Yes, sir.
This one, some maintenance persons, they came for the working here. So I have taken from them. See here, this one, they have provided a clamp like this. Whenever the conductor will comes inside this one, either conductor hai, हमने उसको अंदर लेने का इसमें. So because of this pen it act as a conductor, primary winding. This one inside that one secondary winding is there. We are going to measure the current here. This is bar type as well as toroidal type. We are going to use this stuff. ले लो जी. Just to show करने के लिए थे, उनको दिखाना था. Okay. So it has three types of current transformers. So in the tomorrow class, we'll discuss about the, what is that one? The derivation is there. That derivation, phasor diagram of CT, PT, and for the CT, the transformation ratio. I told that one equation for the transformation ratio. Then error, phase angle error of the CT and PT we are going to discuss in the next class. We'll discuss that. Any doubts here? इसमें कुछ doubt है क्या?
No, sir.
Just now I have shown the device also. That is, you people are lucky. The persons came here and I have shown that one. So you'll get the idea about that one, how they are going to measure. Okay. So this is the actually the derivation for the current transformer we are going to consider here. No. So this is the equivalent circuit we have used. The resistance of primary winding, secondary winding, reactance. Resistance reactance came here. Here the resistance inductance is there. Here the resistance reactance is the inductance is there. Is nothing but reactance we are going to use. X, and X here. No. RP, RS, RE. This is excitation resistance, primary resistance, secondary resistance. Same like secondary reactance, excitation reactance, and primary reactance here. So that one we have written here. Now RS is the resistance of secondary winding, XS is the resistance of secondary winding, like this. So the whole thing I will explain in the next class. It will take complete 1 hour for the derivation. Okay. So I have directly taken your joined. I have not taken your roll numbers. I will take the attendance just a minute. Roll number 1 is present. 2, 3, 4, 5. Roll number 6. Are you there? 7, 8, 9, 10 is also present. 11, 13, 15, 16, 17.
17
Huh? Yes?
present.
कौन है? Roll number
17 present, sir.
17 present है ये. ठीक है, 17 present. 18 is also present. 19, 24, 25, 27, 29, 31, 34, 31, 34, 36, 37, 38. So I will call the once again roll number absent numbers 6, 11, 13, 15, 19, 24, 25, 27, 29, 31, 34, 36, 37, 38. So these many are the absent students who take care about your attendance and all the things. Okay. So we'll discuss this all the things. See, this is the phasor diagram we have to discuss. I think you have studied. Then also we are going to discuss this potential transformer. Again, it is also having the phasor diagram here. This phasor diagram is there. This one we will discuss that one. We have to derive this equation and the difference. Hardly it will take 2 classes to finish this chapter. 2 or maximum 3 classes. So for the 5th unit, 4 hours is enough. 6th unit, 2 hours are enough. According to that, hardly this 4 plus 2, 6, 6 plus 3, 9 lectures are required. So according to that, we'll plan that one. And if you have any doubts, you can ask now. ENTC students, CSE background students, are you understanding? To tell me properly. I will change the tune of explanation and all the things. According to you only I am explaining now with detail. Then also if anything problem you can suggest. Roll number 12, 10 आपके लिए unmute करो, at least बोलो something. Yes?
Yes, sir.
Any difficulties?
No, sir.
No understanding now.
Yes.
Okay. Okay. So we'll stop here only and we'll continue in the next class.